Hi guys, today I want to introduce you to a topic many Year 13 students have found quite challenging, and that's integration by substitution. So why is this such a persistent problem? Well, maybe it's the introduction of new variables such as u, or for more difficult questions, it's the unseen substitution where students have to decide for themselves which substitution to use. So let's start off with example 1. Use the substitution u equals 1 plus x to find the integration of x root of 1 plus x with respect to x. Now it's quite obvious that the substitution 1 plus x is already embedded in part of the question. You can see that underneath the square root. However, before I put pen to paper, what I want to do is discuss the common mistakes made, and that is the notion of the dx. And the assumption is dx and du are exactly the same. I'm going to stop you there. Please never make an assumption that when you replace dx, it always goes to du. Having said that, there are times, and I'll show you these from my examples, that dx and du are the same. But many times they are not. Okay, let's start off by writing out our substitution. U equals 1 plus x. I'm then going to differentiate this with respect to x. So I'm going to have du dx is equal to 1. And in turn, I'm going to break that up and make du the subject. So du equals dx. That's why I'm going to pause for a bit and focus here. Exactly what I was talking about earlier. In this particular case, du and dx are exactly the same. Well, why? It all comes down to this equation here. When we differentiated 1x, it simply became 1. And for that reason, du and dx in this case happens to be the same. Okay, I'm going to continue this by writing out the question. So integration of x square root of 1 plus x with respect to x. Okay, let's focus here. This expression here is actually made up of 3 components. 1, 2, 3. And what we need to do, the aim of this question, in order to proceed, is that each of these components must be changed to an expression that involves only the letter u. Okay, I'm going to break this up into small parts. If I break this up here, I'm going to write integration sign. I'm going to write x. I'm going to write the square root of u because I know that 1 plus x was u. And then I'm going to write dx. Now it's quite obvious from here that I can't continue with that because I have a hybrid of 2 different letters. Really important that this x here and this dx here must be changed to an expression that involves only u. Well, if you look at this equation here at the front, surely x can be made the subject by taking away 1, and this dx from here happens to be du. So it makes sense for us to write the integration sign, u minus 1, which I'll put in brackets, square root of u, which we know as u to the power half, and dx, and only in this case, dx happens to be du. Okay, I'm just going to write that last line again. So we have integration of u minus 1, u to the power half, du. Now, it makes sense now to expand the brackets. So we're going to have integration sign, u to the power 3 over 2 minus u to the power half, du. Now, this is not integrated yet. Just want to point out this is now ready to integrate because these letters here happen to be the same as the letter there. The x has disappeared. So now let's integrate. U to the power 3 over 2 becomes u to the power 5 over 2. But when you divide by 5 over 2, the laws of reciprocals say that we can multiply it by 2/5. Take away u to the power 3 over 2. Instead of dividing by 3 over 2, we can times by 2/3. Now that is now nearly quite finished. All we have to do now is replace the u with the relevant substitution. So we have 2/5, open bracket, 1 plus x to the power 5 over 2, minus 2/3, open bracket, 1 plus x to the power 3 over 2. And if you look at the original question, there are no limits on the integration, which means we can end our answer with an arbitrary plus constant. And that will be the answer to example 1.